So we are having equation 3, that's the solution, that's our differential equation, is a non-homogeneous differential equation, and we are having two parts of solution. We say yc is equal to y equal to yc plus yp. So first we find the homogeneous part of solution, that's yc. We make the substitution y is equal to e to the power mt. So we get here the characteristic equation, that's m square, m4 minus 1 equal to 0. Now you know the factorization is not difficult. We get m square minus 1 into m square plus 1, and m square minus 1, that give me m minus 1 into m plus 1 into m square plus 1. I find the root, my roots are m equal to 1, m equal to minus 1, and m equal to plus minus I. That is the complex. We mix roots, we have the real roots and also the complex root. I can write my solution yc, that c1 e to the power mtm is 1, and c2 e to the power mtm minus 1. Then alpha is 0, beta is 1, so we get c3 cosine t plus c4 sine t. This is the homogeneous part of our solution of the differential equation. Now we want to find the particular solution. Our left hand side f of t is minus e to the power minus 2t. So we will get the value of yp, we will get a because it is only constant, so we get a. If it is a variable t, then we get at plus b. If it is t squared, then we get at squared plus bt plus c. So here is only constants, we get a e to the power 2t, then we take the derivative y dash is 2a to the power t 2t, y double dash 4a e to the power 2t, y triple dash 8a e to the power 2t, and then fourth derivative will be 16a e to the power 2t. We substitute these values of y, fourth derivative and value of y in equation 3. We get here 16a e to the power 2t minus a e to the power 2t is equal to minus e to the power 2t. So we take the coefficient will be 15a is equal to minus 1. A is equal to minus 1 upon 50, and or yp is minus 1 upon 50 e to the power 2t. So I can write my y. My y is equal to c1 e to the power t plus c2 e to the power minus t plus c3 cosine t plus c4 sine t. This is my yc. My yp is minus 1 upon 15 e to the power 2t. This is my number 5. So I want to find the value of x. As I told you, from equation 2 we can find the value of x. In equation 2 we are having here, we can rewrite it. Our x is equal to d2y by dt square minus plus 2y, minus x is equal to d2y by dt square plus 2y. At the end I will multiply by x. I need here second derivative. So first I find the derivative for y, and then I substitute this derivative in our equation here, and I can take it number 6. So y dash, we get here dy by dx, y dash is equal to c1 e to the power 2t minus c2 e to the power t minus c2 e to the power minus t e to the power minus t e to the power t, and then we are having here plus minus c3 cosine t, then plus c4 sine t, then we get minus 2 over 15 e to the power 2t. Then we have to multiply by 2 and add to this one. We get here plus 2 c1 e to the power t plus 2 c2 e to the power minus t plus 2 c3 cosine t plus 2 c4 sine t, and we are having here minus 2 by 15 e to the power 2t. Adding it, we get here y dash is equal to, we are having here 3 c1 e to the power t plus c2 e to the power minus t, and get plus c3 cosine t plus c4 sine t, and minus 4 by 15 e to the power 2t. Similarly, I find y double dash, and my y double dash of simplification will become c1 e to the power t plus c2 e to the power minus t minus c3 cosine t minus c4 sine t minus 4 by 15 e to the power t. So I substitute here the value of y and y double dash in equation 6. I'll get here minus x is equal to c1 e to the power t plus c2 e to the power minus t minus c3 cosine t minus c4 sine t plus 4 by 15 e to the power 2t. Then we have minus 2y, multiply here y by minus 2, this one here, the equation 5 by minus 2, and add to this one. We get here 2 c1 e to the power t plus 2c2 e to power minus t plus 2c3 cosine t and plus 2c4 sine t, and then we get here the value here plus 2y, we get here minus 2 by 15 e to power 2t. So this is the value I get when I multiply by minus. Now here I am just going to multiply, adding and multiply here minus x. We get here the value is equal to 3c1 e to power t plus 3c2 e to power minus t plus c3 cosine t plus c4 sine t, and I am going to get here this equal to, I am having here a difference in sign, so I am getting here minus sign, and I get here minus 6 by 15 e to power 2t. I multiply minus 1, I get here x equal to minus 3 c1 e to power t minus 3 c2 e to power minus t minus c3 cosine t minus c4 sine t plus 6 by 15 e to power 2t. So this is my solution. So the solution of my system is, solution of the system I write here the value for x and y. Solution for the system of differential equation is my value of x. My x is equal to minus 3 c1 e to power t minus 3 c2 e to power minus t minus c3 cosine t minus c4 sine t plus 6 by 15 e to power t, and I have the value of y. My y is c1 e to power t plus c2 e to power minus t plus c3 cosine t plus c4 sine t minus 2 by 15 e to power 2t, e to power 2t, also here e to power 2t, and here we are also in the solution we are having e to power 2t. So this is how we can solve our non-homogeneous differential equation. As I told you, the special thing in this one was that we get the equation 1, also we having very second order. Equation 2 was also second order, the total order was 4, and we get 4 arbitrary constants c1, c2, c3, c4, and equation was non-homogeneous, and we solve it accordingly. Thank you very much.